Case 3 is when your denominator has an irreducible quadratic factor. So an irreducible quadratic factor is going to look something like this. Either x squared plus 4 or x squared plus 7x plus 4. Or in other words, x squared plus a number. That's going to be irreducible because to factor it would require complex numbers. And this over here is just something that can't be factored. If that happens, then what you want to do is include this in your partial fraction decomposition. You just put that whole, the whole thing in its own fraction, and up top, instead of just one letter, you put in ax plus b, or whatever part of the alphabet you've gotten to so far. So, and from there, you deal with it much like we did example 204. So let's look at this thing. Write out the partial fraction decomposition for this. All right, for this thing, it's going to be, let's see, we've got x squared plus 4. That's irreducible quadratic. X plus 1 squared. We have to do that to the first and second power. Then x minus 2. So we get those for our denominators. In our numerators, this one's going to be ax plus b. This one is c, d, e. Now sometimes people say, why does this one have an ax plus b and this one doesn't? Because they're both quadratic. Well, this one is a repeated quadratic. I'm sorry, it's a repeated linear term because it's x plus 1 squared. This is something that can't be factored. So if it's quadratic that can't be factored, that's when you put ax plus b. You know what? Let's do one more example of this. Let's say you've got something over x squared plus 4, not 4. We just did that. X squared plus 5. Yeah, that's vastly different. X squared plus 5 times x plus 1 squared times x squared plus x plus 1. And who cares what's up here? This would split into x squared plus 5. Then x plus 1 would have to show up twice. First power and the second. And this last one, you can't factor it. If you could, you'd have two numbers that would multiply out to 1 and add up to 1. And so it's not factorable. So we do this, and then for our letters on top, this one and this one are both irreducible quadratics. So they'd get the ax plus b. So we get c, d, ex plus f. We're going to skip ahead to example 303 because it's significantly easier than example 302. Example 303, we've got a linear factor and an irreducible quadratic factor in the denominator. So let's split that up. We'll get, let's see, we've got 2x squared minus x plus 4 over this. I'm going to split that into a over x plus bx plus c over x squared plus 4. All right, let's multiply everything by x and x squared plus 4. And what do we get? We get 2x squared minus x plus 4 equals a times x squared plus 4 plus bx plus c times x. All right, so we've got to solve for a, b, and c. The only thing we could plug in here to solve for something immediately would be to plug in x equals 0. If x equals 0, then this side over here is going to be 4, and the other side, this is going to be 0, and this gives us a times 4. So a is 1. Okay, now to get our b and c, we've just got to multiply the stuff out. And let's just go ahead and multiply it completely. We get ax squared plus 4a plus bx squared plus cx. If we look at the coefficient of x squared, on this side over here, it's 2. And on this side over here, it's going to be a plus b. So that immediately gives us, if a is 1, then b's got to be 1 as well. And what's left? We've got to solve for c. C is here, so let's look at the coefficient of x. On this side over here, it's -1. On this side over here, it's c. So that gives us c equals -1. So I can rewrite my integral here as integral of 1 over x plus, let's see, bx plus c. So that's x minus 1 over x squared plus 4. All right. So now we've got to split that one into 1 over x. I'm just going to split this into 3 integrals. X over x squared plus 4. And then 1 over x squared plus 4. All right. This one's going to give us a natural log. This one we've got to do a u sub. And this one is going to be an arctan. So let's work. The only one that's really any work to do is that middle one. The middle one, we've got to let u equal x squared plus 4. Du then is going to be 2x dx. So we're integrating, let's see, x dx is 1/2 du. And the u is on bottom, so we get 1/2 natural log of u. I'm going to go ahead and write that as x squared plus 4. Let's see, that first one is just natural log of x, absolute value of x. And the last one is going to be minus, using my formula, it's minus 1 over 2 arctan x over 2 plus c.